Okay, in this video, we're going to go over the middle section of the chapter on lists. Um, so this is going to be some more things we can do with lists. So remember, we have our basic features. We have our, find where I'm at. We have on our list one, let's say it's equal to, let's have something here. 3, 5, 7, 3, something different too. It could be the same. Let's say we've got that random funny looking list there. Okay. I don't know what that did. So, oh, that's just what ran. Okay, which is fine. Get rid of it though. Okay, don't want to run. Let's stop. Oh, there's a separate one, so let me delete that one. Okay, there we go. I guess I duplicated it or something, but now I just killed that. Now it's doing something else weird. Okay, it's one of those days. Can I undo? Undo delete cell. That's not what I wanted to get rid of. So let's do it again. Okay, so let's say list A is equal to, I don't know, 4, 7, 23, 1, and 56. Doesn't really matter. Okay, now we should be set up. Sorry for that distraction there. So the next section we're covering today talks about figuring out whether or not an item's in a list. Okay. So the simplest way to do this, we can just say if we're going to use the in keyword. Okay. We're going to say some item. So if 7 is in list A, okay, if it is, it'll return true. So I print found 7. We can have an else. 7 not in the list. Okay, so if you run this, it should be pretty basic. It should say that you found 7 because that's true. Okay, so that's kind of a weird way to do it. So let's expand this out a little bit. Instead, we could say, we got a search feature as part of something else. So we can say the search term we're looking for. So let's just say it's often called K. We'll say K is equal to int input enter an item to search for. Okay, we want to do some kind of check here. We'll make sure that we're doing exception checking. Okay, and then we're just going to say instead of this, if K in list A, then say you found K or K not in the list. Okay. Or a little more professional, we could say K is in the list. Okay. So now when we run it, we're going to ask them a question. Let's say I'm searching for something in the middle, 7. Again, 7's in the list. Run it one more time. Let's say I'm searching for the last one, 56. That's in the list. Let's do it again. Say I'm searching for 99. 99 is not in the list. Okay. So that's pretty simple, but it comes in handy. Again, if this were a more complete program, I would want to take all of this is the part we care about. So take this, indent it over, put it under a try block, and then down here have at least an except on the value error. Okay, and then print something. Must be a number. In this case, I mean, if it's not the case, and of course all of this, while we're at it, let's just be totally correct and make sure that we're in a main function. And of course, I need a full comment block, which I don't have. This example. Okay, so we've got that. It doesn't like my value error. Why not? Is that not lined up properly? Give me a capital V. Yeah, capital V. Okay, now we should be okay. Okay. Now we run it, enter item search for, we enter F. It's going to tell us it must be a number. Okay. We'd want to put a general exception there as well, but that's distracting us from the main point of this. Okay. So the next thing that I want to do here is the next section talks about some of the built-in functions, which are very useful. And we've already used one of these in lab, and that's the append function. Okay. So again, this could be part of a broader program. We can say input, enter an item to add. Okay. In this case, we would say list A dot append K. Okay. And the list can hold anything. In this case, we're making sure it's a number or an integer because we're doing that conversion, but you wouldn't have to. You could store whatever you want. Okay, so now if I run that, it's not going to tell us we've done anything. So let's go ahead and now we've done that. Let's print list A. Not a pretty way, but it's a fast way. So we'll enter a 6 here. We now see that 6 is added to the end. Okay. So that's how that function works. There's some other functions that are listed in your book. Append is probably the most important one. There's an index. So index will return the index value of an item whose value is equal to the item. Okay, so if we do something like print list A dot index 23. Okay, then it's going to, we're still adding an item 4. Okay, it returns a 2 here because 0, 1, 2 is the position where 23 is stored. Okay, sometimes that's a useful thing to do for sure. But note that if it doesn't find it, this returns a value error, which is kind of an odd thing. So if I'm looking for 99 and run this, so it asks me to add 1, add a 3, it's going to see must be a number. Okay, so if you're doing the index, you have to make sure that you're dealing with, if it doesn't find it, it's going to return that value error. So what we could do instead, we could say if 99 is in list A, then we do this. Okay, that way you're protecting yourself from getting that value error. Okay, there's also an insert. Okay, so the insert works differently in that we can insert at a particular position. Okay, so the append just adds it to the end, and that's fine. But if we're going to, instead, we're going to insert, let's say we want to do at position 2. Okay, when we do this, and enter a 99, I didn't print out the list, so it's not going to show us. So let's print out the list again. What isn't it like? Oh, I have to insert what I'm inserting and where I'm inserting it. I'm inserting K at position 2. Okay, that should be okay. But now, I need to go ahead and print. Okay, that's again. Run this and enter. Doesn't matter. 6. No, do 66. Okay, and now it didn't add 66. Why not? Oh, got it the wrong way. It should be the 2. So it wants the position first and then the item. That's what I did. Try that now. Okay, enter 99. Yes, now at 0, 1, 2, we have entered that item. Okay. And it was odd before when I gave it an invalid index. I guess that's good to know. It just didn't insert it at all. Okay. But notice everything else gets pushed off when you do that. Okay. There's a remove. Okay. So you can have item to remove. And then just do a remove. Okay. Okay. So I do this. Can run it. Item to remove. So I'm going to remove the 23 from right in the middle. See, the 23 is now gone. Nothing shifted around. Okay. On the remove, if you try to remove something that's not there, okay, remove 99. Again, it gives me the value error. Must be a number. Okay. So again, I would want to put, before I remove something, I want to make sure it's really there. So if K is in list A, then I can do my remove. Okay. Same reason. Okay. So the other ones here are interesting as well, and they allow us to sort and reverse sort things. Okay. We've got this list here, so I'm going to print it out first, and then I'm going to print out list A dot sort. Okay, take some parameters. You run it. I did something wrong. What did I do? Sorts the item in the list so they appear to be in ascending order. Right? It's a dot sort. Okay. I don't know why that didn't work. Should have. What if I say list A is equal to list A dot sort? Then print list A. Did that fix it? Nope, did not. We are killing list A somehow. That's really, I wonder if that's a Colab issue. I can't imagine. I should be able to say this. And it shouldn't take anything. Oh, that did it. That's really strange. I guess you can't do that as part of another calculation. It must not return anything, which is weird. Okay. So yeah, that worked. You see now that it's in the correct order. Okay. And the other option here is to do reverse. And reverse just puts it in order from. That's weird. The reverse didn't 100% work. It did change it, but it put the 1 in the wrong place. Yeah, I'm not sure what happens. That's really strange. Everything else is okay. Just put that 1 someplace different. Yeah, I don't know why. What if we make that something different? I don't know if I did something weird with the 1. Make it 11. Nope, that position is just weird. Let me get rid of that altogether. Yeah, now it's okay. What if I put a 1 back in there? Oh, there's something special about 1s or what it's doing. Yeah, that 1 is just messed up. I'm gonna look that up. That's really strange. But in general, it allows you to reverse sort things. It didn't have any problem sorting it going forward. So yeah, who knows? So those functions are pretty useful, and you should know those and use them when appropriate. Okay. There are also some functions that take parameters. Okay. So those look a little bit different than other things. Okay. So I guess the first one is even weirder. It's this delete statement. So the delete statement, it will take a list item, okay, and it will delete that. Okay. So that is going to and it's weird that it's different from the others. So in this case, if I want to get rid of, I don't know what's there, okay, but I want to get rid of whatever's at position 2, which is the 23. I can do a delete list A, okay, at that position, okay, which is 2, okay, and then print list A. See if that worked. And it does. Now it's gone. So it's weird. It's weird that it's off by itself. Again, the delete is going to be used in other places, but it's not a function. It's just a statement, which is strange. And then the other thing that we'll talk about, we saw this in the lab as well. There are functions that take lists as parameters. Okay. And that's like the max and the min. Okay, so I can just print out here max or min of list A, and it will print out the biggest item. Okay, min works the same way. Okay, so we have the remember where they go. We have the functions that go with a dot. That's the append, that's the sort, reverse, insert, remove, all those. Okay, we have the delete function, which is weird and kind of stands on the delete statement, not a function, that takes a list with an index and removes that from the list. Okay, and then we have the functions that take list as parameters, the max and min. And there are others, but this is what we have so far. Okay, so the next section is going to talk about copying lists. Okay, so the first thing we can do here, we can just create list B is equal to list A. Okay, and then we can just print out list A, comma, list B. Okay, so you do that, there's our two lists. Okay, let's just say we're going to change list B just for craziness. We're going to take the first one that was a 4 and make that now equal to a 44. Okay, we do that, and you should have noticed an issue. Okay, the issue is this is list A. I told list B to change, not list A. Okay, the problem is that this is what's called a shallow copy, and it creates something called aliasing. Okay, so sorry, I'm in the wrong language. That's what I want. Okay, this is a bad thing. I'm not sure why it's a feature. I don't know why you would ever want to do this. Okay, it's kind of like giving it an alias. I guess it's called aliasing. So it's kind of like if you have a kid named Bob, and you decide that you want two kids, so you're going to also name Bob Tom. I've got two kids, Bob and Tom. They're the same kid, right? So you're not really creating two objects. So this is not what you want to do hardly ever. Okay, because it's not really doing anything for you. Okay, so if you want to have that be different, where you're not just creating a list that that is a just another name for the same list. Okay, you can do the following. You can do bracket colon. Okay, so that's saying start at the beginning, go to the end. Okay, if I do this, now you see that my original list A was unchanged. Okay, but my list B, where I wanted the change to be made, has been made. Okay, and what we're doing there is that we're just going through and writing out this list and reading it into this one. Okay, so this is actually, that's a shallow copy. Okay, and then below it we'll do list C, for example, is equal to list A colon, just like that. Okay, this is what we call a deep copy. Two actual copies are made. Okay, and that should take care of that problem. Okay, so the other thing we do, the next section, last section we're going to talk about today, talks about processing lists. And my dogs are having a fit in the backyard, so you may hear that. How we process a list. Okay, so and we saw that in lab today, so this shouldn't be new, but it's the idea you're going to go through a list and you're going to get information or print something out, whatever you're doing. Okay, so they've got this example in the book that talks about getting employees information. Okay, so we're going to have here an hours function or an hours list. Okay, we're then going to go through and we're going to and this assumes that we've created a number of employees. So let's go ahead and do that like they're doing. Is equal to 6. Okay, let's do 3 to make it quicker to test on the video. So the video's not too long. So in our main, we're going to let hours to be equal to a blank list. They go ahead and prepend it to zeros everywhere, but I don't think we need to do that. Let's see what they're going to do differently than what I would have done. Okay, we're going to enter that. Okay, they're not inputting. That's really strange for index and range. Oh, they're entering it there. Oh, there's a float input. Okay. That's a weird structure. Let's do what they're doing. It's really strange. I'm not 100% sure why they're doing it this way. I wouldn't do it this way, but we'll follow their lead at first here. So we're doing it times the number employees. Again, it's in all caps because we're assuming that's a constant. Okay. And then they're saying for index in range, number of employees, which makes sense. Okay. For each one, we're going to print enter hours. They put, well, that's all they care about. Worked by employee. Oh, and they're using the index here. By employee. I'm an index +1. Again, you don't have an employee 0 probably. And then a colon. And then they've got a sep equal to nothing. And the end equal to nothing to keep it right there. Okay. Printing all that. And then we're saying hours sub index is equal to float input. And this is kind of a weird way of doing it, but all it's doing here, I'll make my screen a little wider and really mess with your videos, see what I'm doing wrong. That. What doesn't it like there? Index +1, index is okay. Oh, missing a comma. That's what I always forget. Okay, that should be okay. Okay, so what they're doing here, they're separating out. They're not putting a message on the input statement. They're instead putting it as a print statement with no separator and no inline, so it stays on the same line. Okay, and they're doing this to allow them to say employee 1, employee 2, employee 3, and so forth. Okay, which I think makes sense. But I would have used an append instead, but this should work. Okay, and then they're just doing the. I'm just going to put a pay rate here as the same. Let's say we have all the same pay rate. So pay rate 15.0. Okay. We can then loop through and display each employee's salary. Okay. So we've got for index in range of num employees again. Okay, that's going to go up to, but not including. So that's going to give us, since it's 3 right now, 0, 1, and 2, which is what we want. Okay. And then we're going to calculate the gross pay to be equal to the hours for that employee. So the hours of index. Okay. Times the pay rate. Okay. So that's going to give us the gross pay 1 by 1 for employee 1, employee 2, employee 3. It's not maintaining that. Then it's going to go ahead and print it out. Okay. Print out gross pay for employee. Index +1. And then we can print out what that is. Okay, we can do a format on the gross pay with the point to F. Okay, that should finish that. Okay, sorry, I had to pause that there real quick. Okay, so we're saying we're going to print out the gross pay for employees as a string. We're going to print out index plus one again because people don't assume there's a zero for that. I'm missing a parentheses on the end. That's what I'm doing. Okay, so that's going to print again. We're not saving that information, so we could have a gross pay array or list if you wanted that would just go through and do all of that. But in this case, we're just going to print that out. So let's see if we get this correctly. So employee one, and again, that shouldn't pop down, but it does in Google Colab. I'm not sure why. Let's say they worked 20 hours, employee two worked 30 hours, and employee three worked 40 hours. Okay. And you see those are the amounts that they've worked. Okay. Again, not great, but you get the idea. So the other thing we could have done here, we could have created a different array here. Okay, so up here, we could go ahead to use our append. We could just say that pay or gross pay is equal to just an empty one. Okay, and then after I did this, I could say, no, I'm calling that gross pay. So let's call that GP or GPay. That becomes GPay down here. Okay. And I can go ahead and append that if I wanted. So I could say gross pay dot append GPay. Okay. And then when I'm done, in addition to printing it one by one, I could just go ahead and print my gross pay list. Okay, let's see if that works. Okay, so again, I'm doing a 20, doing a 30, doing a 40. And you see that I've now created a gross pay list as well. Okay, you may want, you may not want. Okay. In general, you probably don't want actually, because in general, you don't store things that you can easily calculate. But if you needed that for some other reason, you could do that. Okay. So, yeah, that's a processing list. Other things you can do, and again, you saw this in the lab this time, is that you can go through and total up the number of the items in a list. Okay, so if we do this, let's go ahead and get rid of all this. And all the book also has an average as well. Okay, so if I have list A is equal to 1, 2, 3, that's it. If I wanted to get a total of that, let's say total is equal to 0. Let's say for C in length and range, len of list A. And then for each one, I would say total plus equals C. Okay, and then it should be able to print total. Okay, that should work. It should give us, it does not work. Well, let's see why it didn't work. Okay, the length of list A is 3. Oh no, it's not. That's not equal to C. It's equal to list A sub C. That's what I'm doing. That would have been 3. Run that, and it's 6, which is correct. Okay. They also do that for an average. Same basic idea. Okay. You don't have to count a list, remember, because the length tells you that. Okay. So if I just wanted to make this an average instead, I would just say when I'm done with this, we just have average is equal to total divided by the total amount by the length of list A. Okay. And then if I want to print the average, should do that. And the average is 2, which is correct. Okay. You can also pass lists to functions. Okay. So we've seen that before. So if I have list A, I can create a function called print it. Remember, you don't want to print to functions unless that's all they do. That's all it's going to do. It's just going to print it. We'll call it A. We can call it whatever we want inside of our function. Okay. So I'm going to say for C in range of A now, since we're in this function, then print A C. Okay. Don't need to return anything. It's going to do that. Oh, I need to call it though. If you don't call it, nothing ever happens. So I'm going to call print it on list A. Doesn't like something. What doesn't it like? Type error. Well, oh, it's the range length of A. That's what I'm doing. Run that now. Yeah, now that works properly. Okay, so you can send it to a function, not a problem. Okay, you can also return it. So up until now, we've only been able to return one item from our function. So let's do an example of that, probably force an example, okay, where we're going to calculate two different things. Okay, so we're going to do something really useless to prove the point. Okay, so let's say we have a function called get two numbers. Okay, not very inspired, but you get the idea. Okay, so we're going to have it n1 is equal to int input number. Okay, noting I'm getting all the squiggles because I'm not actually calling the function yet. Or another number, call it n2. Have those two numbers, okay. And now I can return that list. So I can create a list. So I can say something like, I don't know, let's call it list A again is equal to bracket list A dot append n1 and list A dot append n2. Okay, then I can return list A. Okay, and then from here, I'm going to call the get two numbers. Okay, so I'm just going to call this X. Get two numbers. It doesn't take anything, just returns things. Okay, and then I'll have, if I print X, my brackets, even if I don't, or my parentheses, if I don't do anything. Okay, I'm going to enter a 3, enter a 4. Notice that when it comes back, X is a list. Okay, so if I wanted to, I could print, I could do a for loop, I could do whatever, or I could just do X sub 0, comma X sub 1. Okay, 5, 2, print those numbers. Okay, so lists can go back and forth, no issue there at all. There's some pretty good examples in the book on the processing a list in the Spotlight. Those are worth going through to make sure you understand what's happening with them. Okay. It's also the case that we can work with lists and files together. Okay, that's I think the last section of the last part of this section. Okay, so the idea there is that you're going to be able to either read a file. Okay, so you can read from the file and save each of those items that you're reading from the file into a list. Okay. So, or you could go from a list that you have and write that information to a file. Okay. Take a look at that, what that looks like. Some examples here. Okay. So we're starting with a list of cities. equal New York. Oh, I said a list of cities, but I didn't type in my bracket. Say we have New York. We have Boston. We have Atlanta. And we have Big Stone Gap, just for a local flair. Okay, that's our list. Okay, and I'm not gonna be able to run this because I'm on Google Colab and files don't work there. Anyway, I can do an out file equal open to say cities.txt. I'll open it for writing. Okay. Once I've done that, I can write the list of the file. I can say out file.write cities. Okay. I can then close the file. Okay. And I can do another program that's also there in the book where I'm going to read from the program. Okay. And when I read it in, I'm going to do the read lines. Okay. That's going to read the entire content of the file into the list with the read lines. Okay. And then I can go through and making sure I strip out the new line characters, I can print the contents of the list. Okay. So we may do an example of that in class as well, but that's the basic idea. But I can't really do that here since I'm in Google Colabs. Okay. So that's some more stuff about lists. Okay. So we've got still two-dimensional lists to cover, which look like mathematical matrices to some degree, and a few more things. But that's the basic idea behind some more list functionality. Okay.